Hi, and welcome to a video on L'Hopital's rule. The goal of this video is to apply L'Hopital's rule to evaluate limits that result in indeterminate forms. Now, hopefully you've already used L'Hopital's rule to evaluate limits that result in indeterminate forms that look like 0 over 0 and infinity over infinity. So what we're going to talk about today are indeterminate forms that are a little more strange, which are these guys, and I call them the ugly indeterminate forms. If you get results such as infinity times 0, negative infinity minus negative infinity, or 0 to the 0, 1 to the infinity, and infinity to the 0, you have an indeterminate form. These are all bad, and you know nothing if you get these results. What we want to try to do is make these indeterminate forms look more like these indeterminate forms by forcing fractions to occur, or also by using logarithmic techniques. So essentially we're going to take these indeterminate forms, make them look like these indeterminate forms, and then we can apply L'Hopital's rule. So make sure that you understand when you can and cannot use L'Hopital's rule, and we'll go through some examples so you can see exactly how this is applied. Alright, the first example we're going to look at is the limit as x approaches pi over 2 from the left of secant x minus tangent of x. And it helps if you remember the graphs of secant and tangent. So let's take a quick look and recall the graph of tangent of x and also the graph of secant of x. Alright, so let's use these two graphs to evaluate our limit. As we look at what happens to secant of x as we approach pi over 2 from the left, you can see that secant of x is going toward infinity. And as we look at what happens to tangent of x as we approach pi over 2 from the left, we also get infinity. So we're going to get an indeterminate form here. This is bad. And also you'll notice it's an indeterminate form that we cannot use L'Hopital's on. So anytime we have trig, sometimes we can rewrite these using trig identities. We know that secant x is 1 over cosine x, and we know that tangent x is sine x over cosine x. So we're going to use those simple identities, and now we have common denominators, and we can rewrite this as 1 minus sine x all over cosine x. And let's see if now we can apply the limit as x approaches pi over 2 from the left. Now we know that sine of pi over 2 is 1, so we get 1 minus 1 in the numerator. We know that cosine of pi over 2 is 0, so we get 0 over 0. And this makes us happy because now we can apply L'Hopital's rule. Because we got an indeterminate form of 0 over 0, we can use L'Hopital. So let's go ahead and take and apply L'Hopital's rule to the numerator. If we take the derivative of the numerator, we get negative cosine x. If we take the derivative of the denominator, we get negative sine x. The signs simplify, and now again we're going to take the limit as x approaches pi over 2 from the left. And the cosine of pi over 2 is 0, the sine of pi over 2 is 1, and 0 divided by 1 is 0. So our answer is 0, and we are done. There are several more examples I want you to take a look at. This is just the first one. I have some videos that follow, so please watch those.